The first thing I want to go through is the concept of hypothesis testing. So we've got a really clear understanding of what's going on here. And I want to do it with a couple of examples. I'm going to claim that I've got a miracle packet of biscuits. This packet of biscuits that I've created can cure the common cold in just 3 days. Wow, that's pretty good. And we like biscuits, so I'd be happy with that. The hypotheses are: it's a packet of biscuits. It's not going to work. That is not going to cure the common cold in 3 days. There's nothing special about it. Those biscuits don't do anything. They're just regular biscuits. Or the alternate hypothesis is, wow, they really do work. Now, hold on. We're saying a couple of things there. And what we're saying there, we're saying two things. Not only are we saying that the biscuits are pretty special, that they do something, but we're also saying that the thing that they do is the good thing. Note that we're only interested in the kind of the one tail there. We're not interested in whether the thing that they do is bad. We're interested in, do they do something, and is that thing that they do good? Okay. Now, you're right. It does sound a bit far-fetched. Miracle packet of biscuits, I'm very skeptical. So the thing that we need to do is to do a test, a clinical trial. For this test, I've gone out and I've tested this packet of biscuits on 100 people, okay? And we're going to make conclusions for the whole population based on the results of this sample of 100 people. And that's one of the key things about hypothesis testing, is that what we do is we can't test on everyone. So we go out and we test on a sample and we look at whether the results of that sample are really significant. Can we be sure, or can we be confident enough that the results of that sample indicate that something really does work or not? The significance level I'm going to use for this is 5%. What we're saying there is, from our 100 people, 100%, from our 100 people, if 95% of them are cured within 3 days, then we'll accept that probably the packet of biscuits, on the balance of all the evidence, does work. Okay? What we're doing there is we're limiting ourselves to a 5% chance of incorrectly concluding that it works. So that's of making a false positive conclusion. I did go out and I tested my biscuits on 100 people, and 60 of them that ate the biscuits did recover within 3 days. I was pretty impressed. This figure does seem a little high, and you'd be right. I Googled it. To recover within 3 days of a cold, the average time that people recover from a cold is 7 to 10 days. Okay, so this is a little bit high, but is it high enough to conclude that the biscuits really work? Well, we set the limit at 95%, 95 people or more, before we'd be convinced of their effectiveness, and this falls short of that. So although it's a good result for our biscuits, it's not good enough for our hypothesis test. Our sample looks good on the whole, but maybe we're just lucky this time around with this particular sample. If we were to go out again, maybe only 20% would recover. Maybe it would be more, maybe it'd be less. But the important thing is that it doesn't reach our 95% that we said would be our cut-off point. So there's our hobnobs. The conclusion. Now, it's really important that you do conclusion in context. Don't just say it works, it doesn't work, or don't just say I'm going to accept H1. What the exam is looking for, and the wording here is really important, is that you say something like there is insufficient evidence to accept H1, and then you put it in context. We reject H1 and accept H0, that the new biscuits do not cure the common cold in just 3 days. Now, I said about the wording, okay? We're not saying that the biscuits definitely don't work, but what we're saying is that the results from our survey indicate that they don't. So on the balance of all the evidence that we've got before us, this is going to be the conclusion we're going to make. Now, this table will really help you out with the hypothesis testing exam questions. These are the things that you get marked on, and these are the things where you can score your marks. So, as I've said there, if you don't write anything else down today, copy this one down. And if you aim to fill in all these bits of information on your hypothesis testing exam questions, it's going to get you most of the way there. Okay? Define the variable. What we're talking about. P equals the probability of the biscuits being good. Write down your null and alternate hypotheses. H0, the null hypothesis, is the general case, the case that nothing's special, nothing's changed, everything's normal. We'll go with what we expect or are told the figures should be. H1 is the alternate one, the one that we're trying to test for. The significance level is usually given in the question. The one or two-tailed, that's within the wording of the question. If they don't indicate a greater than or a less than, then you're going to go two-tailed. But if they're looking for just one side, is the probability more or is the probability less, then you're going to go one-tailed. What's the probability of this occurring randomly? That's the bit where you have to then do your binomial distribution stuff and work that one out. And then you're going to compare that with the significance level. If the probability of that thing occurring randomly is lower than the significance level, then you're going to conclude that, wow, under H0, that thing had such a low chance of happening that it was so unlikely that perhaps, just perhaps, H1 must be true. And that's where we decide whether we're going to accept or reject the null hypothesis. And we conclude in context. Going back to that accept or reject the null hypothesis, that is the easiest way to word your answer and to save you getting confused when you're writing these things down. Okay, I said I'd do two examples, so here comes the second example. The biscuits thing, it was a bit silly, let's face it. So let's have scenario 2, developing a vaccine. We want to test whether a new vaccine can cure a virus. So this is a bit more realistic now. This is, real life stuff. The hypotheses are going to be the vaccine is ineffective, or the converse of any of the things I'm about to list down under H1. Because for the vaccine to be used and to be usable, all of these things have got to apply. It's got to work, it's got to be safe, no serious side effects, it can be manufactured quickly in measured doses, and so on and so on and so on. So ultimately, we're going to be giving this to a great many people. We've got to be really sure of our conclusions here, okay? A 5% significance level, that's not going to cut it. We've got to be really sure. So what do? The clinical trial, we use a much larger sample, okay? And within that sample, we got to check and test on all sorts of different variables as well. Ages, genders, so on and so on and so on, okay? The significance level, we don't want to be 5% or 95% sure. We're going to be much more sure than that. So we're going to use a much lower significance level, okay? The numbers I've put here, they are pretty much what I think would be appropriate. In reality, I think you're looking at something along those lines, but don't quote me on the exact figures here, okay? Now, the thing is that 0.1%, that might sound really, really small. However, if you're talking about testing this or using this on the whole world, 0.1% of 7 billion people is still 7 million. So we've got to get this right, okay? What have we got here? In order for the vaccine to be approved for general use, the trial must demonstrate sufficient evidence that there is less than a 0.1% chance that the sample would have recovered without the vaccine anyway. So i.e., we're saying that there's a less than 0.1% chance that our conclusion would be wrong. We don't want to have what's known as a false positive or a type 1 error. We falsely claim that the vaccine works.